Hi, my name is Fatma Zoroğlu Çağlar. I am a doctorate student at the Building Physics in Architecture and I am a research assistant at Yıldız Technical University. The title of our publication is The Impact of Transparency Ratio on Visual Comfort, the Case Study of an Educational Building in Istanbul. Visual conditions in educational buildings play an important role in the efficiency and health of the occupants. However, it is not given sufficient importance to ensure compliance with visual comfort conditions in the design of buildings. This study aimed to determine the visual comfort conditions and to suggest for improvement in an existing educational building. In the presentation, we will talk about the study steps, which are introduction, methodology, daylight and lighting standards, results, discussion and conclusion. When the necessary visual comfort conditions are not met, psychological and physiological disorders can be observed. One of the parameters in the standards in determining the visual comfort conditions is the determination of the illuminance level values. The main determining parameters in the calculation of illumination level values are the dimensions and light transmission properties of the transparent components. Studies have found that daylight has a positive and highly significant association with improved student performance. However, improper planning and uncontrolled daylight can cause inconvenience and negative consequences. An appropriate transparency ratio improves visual comfort and reduces energy consumption. Students and academicians have a significant share in the population and spend most of their time in university buildings. Therefore, appropriate visual comfort conditions are of great importance of those users. Although there has been a lot of research in the transparency ratio and visual comfort, there are few studies on the evaluation of existing educational buildings with the 5 studies. This study aims to evaluate the effect of transparency ratio of an existing higher education school building on the visual comfort conditions of the classrooms according to standards. Visual comfort may be determined with different methods. Most common practices are objective method. This method used in the study for comparing the results and determining the visual comfort. In this context, daylighting and integrated lighting level measurements were carried out in 4 classrooms with different transparency ratios in the same direction in an existing school buildings. And then, the data obtained were evaluated according to standard. Istanbul is the province with the highest number of universities, students and academicians in Turkey. The first study was conducted on Yıldız Technical University in Istanbul B block in 4 classrooms. The classrooms are on the 4th and 5th floors. The southern facade is the most effective facade in daylighting. For this reason, classrooms with different transparency ratios on the south side have been determined. There is no obstacle that prevents daylighting from the south in the classrooms. Since visual comfort depends on many factors, the other properties of classrooms such as environmental conditions, orientation, room dimensions, high above sea level, the building envelope properties, the material properties, etc. should be as similar as possible. The properties of classroom with rectangular plan and trapezoidal prism and transparency ratios of classrooms are given in Table 1. The building envelope material properties of classroom are same. The difference between the transparency ratio of the southern facade is quite large. We can see the interior of classrooms in figure 2. In order to benefit from daylighting, the classroom is positioned incorrectly. The writing boards are located at the deep point of the classrooms. Daylighting comes from behind according to students' perspective. 5 studies were carried out on 20th December 2019. Daylighting and integrated lighting measurements hours are determined between 12 and 14. Horizontal illuminance level in the workplace and vertical illuminance level on the writing board was measured. The measurements were made in clear sky conditions with the curtains open. Konica alta illuminosmeter was used in the measurements. The measurement points are determined by taking into account the plan of the classrooms and the seating arrangements. You can see the measurement points of classroom in figure 3. Measurements were carried out at 7 different points in each classroom. Also, the measurements were carried out in shaded and unshaded areas to show the effect of daylighting in B502 classroom. Another step of the study is the daylighting and lighting standards. Two standards are used for this for visual comfort criteria that must be specified for daylighting and lighting in Turkey. There are criteria for natural lighting in the TSIN 17039 daylight in building standard. The criteria are grouped under 4 headings such as daylight provision, establishing with without, exposure to sunlight, protection from glare. The daylight provision by daylight openings in a vertical, inclined surface and horizontal surface are recommended as the minimum, medium, and high target illuminance level. The average minimum level should be at least 300 lux in 15% of space at least and 100 lux in 95% of space at more than 50% of the daylight hours throughout the year in vertical surfaces. The average minimum luminous level should be at least 300 lux in 95% of space at more than 50% of the daylight hours throughout the year in horizontal surfaces. The criteria for artificial lighting are evaluated according to function of type of activity or area in TSIN 12464 light and lighting of workplaces part 1 indoor workplaces standard. The evaluation criteria of the standard are classified under the topics of illuminance level, luminance distribution, glare and color aspects. This standard stated that maintain the luminance of the interior as at least 300 lux and minimum illuminance uniformity as at least 0.6. In addition, the mean illuminance level at least 500 lux and the illuminance uniformity at least 0.7 is given for black, green and white writing board lighting in educational buildings. In this study, the illuminance level criteria specified in both standards are used for comparison. Another step of the study is evaluation measurement results. When the spaces are illuminated by daylight, illuminance level of 95% of B402 and B403 classrooms are under 300 lux. The illuminance levels of B502 and B503 classrooms are provided minimum limit values given in the TSIN 17039 standards. In integrated lighting, the illuminance level is more than 500 lux in all points of the classrooms. In the integrated lighting of classrooms, the illuminance level of each point is more than minimum illuminance level given in TSIN 12464 standard. This standard provides high target illuminance levels given in TSIN 10039 standards. In classrooms with high transparency ratio illuminated by daylighting, the illuminance level of the points far from the window is quite low compared to points close to the window. In classrooms with low transparency ratio, there is not much difference between the illuminance levels. The difference between the illuminance levels of the measurement points is lower in integrated lighting than in daylighting. In addition, the illuminance level in integrated lighting are higher than daylighting. The illuminance level in the workplace is higher throughout the light reflected from the wall surfaces in integrated lighting. The lowest illuminance levels are at the 6th point, and the highest illuminance level are at the 1st and 3rd point in both illumination. In classrooms with low transparency ratio illuminated by daylight, the illuminance levels of the 4th, 5th, 6th, and 7th points are less than 300 lux. The measurement results of shaded and unshaded points are given in Figure 6. The shadows of the window frames occur near the 1st, 2nd, and 3rd points in B502 classroom. The difference between the illuminance level of shaded and unshaded points is greater in daylighting than in integrated lighting. When classrooms with high transparency ratio are illuminated by daylighting, the difference between their illuminance level is high. The illuminance level on writing board is higher in classroom with high transparency ratio than classroom with low transparency ratio. The illumination level on writing board is higher in integrated lighting than daylighting. While the writing boards are illuminated by daylight, it is determined that the illuminance level in 50% of the workplaces is below 300 lux, but 95% of the workplaces are illuminated over 100 lux in B402 and B403 classrooms. The illuminance level of writing boards of B502 and B503 classrooms provides minimum limit values given in the standards. The average illuminance level on the desk is more than 300 lux in daylighting and more than 1000 lux in integrated lighting. The illuminance uniformity is more uniform in integrated lighting than daylighting. The illuminance uniformity doesn't provide minimum value given in standards in both illumination. The average illumination level on the writing board doesn't provide a limit value of at least 500 lux in classrooms with low transparency in daylighting. The average illuminance level on the writing board in all classrooms is more than 1000 lux in integrated lighting. The illuminance uniformity on the writing boards provides minimum value given in the standards in daylighting. In integrated lighting, the illuminance uniformity on the writing board is less than 0.35 and is lower than the limit value given in the standards. The conclusion of the 5 studies are classrooms with high transparency ratio have a higher illuminance level, but classrooms with low transparency ratio have a more uniform illuminance distribution. The illumination levels in integrated lighting are higher than in daylighting. Illumination levels have increased in integrated lighting. This increase is higher in classrooms with low transparency ratio. Since the opaque surface area is more in classrooms with low transparency ratio, reflected lights are also higher. This situation has resulted in an increase in the illuminance levels and uniform distribution in integrated lighting. The depths of classrooms are high, sunlight don't reach the innermost parts, and the plan is not designed for daylighting. Since the sunlight cannot reach the innermost parts, it causes a big difference between the illuminance level in general at the points. This difference is partially less in integrated lighting and less in classroom with low transparency ratio. Also, the sunlights come from behind the students. There are large differences between the illuminance level of shaded and unshaded points, and this situation can create discomfort. When illuminated with daylight, the illuminance levels on the writing board are quite lower than the value given in standard in classroom with low transparency ratio. However, the luminance level value is provided in integrated lighting. The limit illuminance uniformity value is provided on the all writing board in daylighting. However, this value couldn't be achieved in all classrooms in integrated lighting. This indicates that the plan of the lighting devices is not specifically designed for writing board lighting. Buildings, especially with a function of education, should be designed by considering daylighting and integrated lighting. In existing buildings that are not designed according to these parameters, measures can be taken to improve them. In classrooms with high transparency ratio, it has been determined that daylight can cause excessive illuminance and improper illuminance uniformity. In rooms with high transparency ratio on the south side, it is recommended to use shading devices in order to prevent negative situation while benefiting from daylight. However, visual, thermal, and acoustic comfort conditions should be considered together in the design of shading devices. In this study, where the effect of transparency ratio on visual comfort is determined, the awareness of architects and engineers on the subject is expected to increase. Analysis must be made for each building separately in the design. In further studies, it is possible to make a more accurate analysis by developing the method used in this study for buildings in different climate types, different orientations, and different functions. Thank you for listening.